So by now you may be wondering about the test of superciliousness. There are 0 glignates in a packet. For number 1, they don't come in packets. I don't know why anybody would think they did. When a glignet turns blue, the chemical reaction is, of course, acid. Anytime a plasma is frozen, the result is frozen plasma. That was kind of a gimme. When arranging glignet in their pens, the best suitable number per pen is 9. The lifespan of a glignet is 30 hours. They don't live that long, come on. Neiman stubs that apply to college usually major in science. This is all information that we should probably know by now. No, but that's okay. You may be wondering why we did the test of superciliousness at all. I mean, it was actually very silly. But the truth is, it's a binomial probability, which you may have figured out from the last video. Here are your results, by the way. The number correct and how many students got that. So one person had 1 correct, the highest was 8 correct, and again, one person had that. And this actually follows a binomial probability distribution pretty well. These people who had 5 and 6 correct were kind of my outliers, actually. I expected more of you to get 3 and 4 based on the expected value for this experiment in the probability distribution. Why is this a binomial probability? Well, there's a finite number of trials. There were 20 questions. That was it. Finite. And on those 20 questions, you had 2 options. You could either have a success or a failure. Okay? They were independent trials. The answer to number 1 did not impact your answer to number 2. And the probability of success is the same for each. Meaning there was 1 correct answer out of the 5 answer choices. And how I got those correct answers was a random number generator. I used a random number generator from 1 to 5. If 1 popped up, I bubbled in A. If 2 popped up, I bubbled in B, and so on. So realistically, the results to this test could change each time we score a new key. Okay? But some key points to take away. N, the number of trials, was 20. And P, the probability of success, was 1 out of 5 correct answers, which is 0.2. Why is this important? Well, it helps me make my probability distribution table. And we've been working with these. These are really important. Remember, they all have to be in decimals, and then they have to add, the probabilities have to add up to 1. Usually we do them vertically because we have 20 questions or 20 trials that potentially could be correct. I'm going to do mine horizontally. So the probability of 0 correct, 1, 2, 3, 4, 5, and so on. Okay? You can fill in the rest as you need. And if you remember from that last video, we have this really great formula where we have the number of trials, n. I should use the lowercase n. My apologies. With a combination x, so n choose x, times the probability of success raised to the x power, times the probability of a failure raised to the n minus x power. And we're going to use this formula to help us build this probability distribution. So if I do 20 choose 0 with a probability of success that is 0.2 raised to the 0th power, anything to the 0th power is 1. The probability of a failure, 1 minus 0.2 would be 0.8. And n minus x, 20 minus 0 in this case, would give me that 20. You can do this all on your calculator. When we plug it in, we should get 0.0115. And I can record that in my table. Okay? I can do the same thing for 1. Anytime I see an X here, I'm just going to replace it with a 1. So 20, choose 1. 0.2 to the first power. 0.8 to the 19th power. And when you plug that in on your calculator, you get 0.0576. With 0.2, same idea. 22, choose 2, 0.2 to the second power, 0.8 to the 18th power. So you can see the exponents here are getting larger, the exponents here are getting smaller. When you punch that in on your calculator, you get 0.1369. Go ahead and try 3 successes and see if you can come up with that on your own. Good, you should have gotten 0.2053, and I'm going to go ahead and just fill in the rest of this table for us. 0.218 and 0.17456. Okay? And these are my expected probabilities from the experiment. So we can kind of see the probability of getting 0 correct is really small. 0.1. I'm sorry, 0.01. So 1% of people get 0 correct. Okay? So your chances of getting 0 were correct was actually pretty, more than 0 correct was actually really good. Your chance of getting 1 correct was 6% or about. And we had 1 person who got that. 1 out of 24 of you was about 4%. So a little lower than what we expected. On the other hand, getting 2 correct, 2 of you did that, and 2 out of 24 would be about 0.08, 8%. So that's a little lower than this as well, okay? But then when we get to 3, that's also going to be 0.8 or 0.08, so still a little lower. This would be 0.125, so 13% approximately, which we're much lower than this expected percentage of 22. And we notice they're getting higher up till 4. So most people I would expect to be in this range. And then it starts going down. Getting 5 correct is only 17%. But in this class, you guys kind of were the exception. 8 of you had that, which was 33%. So this is, again, where you guys are a little bit different. But most of the numbers, if we were to repeat this experiment, would be, most of you would probably be in this 3 to 4 correct range. Okay? Getting more than 10 correct is very, very, very low. Okay? So even getting half of them correct was very low for this. Okay? So how do we use this? Well, you have tests that are like this, 20 multiple choice questions. Maybe not in here, but in other classes. So you could theoretically predict how many you were going to get right without knowing any of the material, because I guarantee you did not know any of the material that was on that superciliousness test. Okay? Your chances of not studying for a test and getting 10 right are very slim. You're probably going to get 3 to 4 right, and that's why we encourage you to study, is because this is a binomial distribution, and we can figure out your probability of getting some right given the fact that you know nothing about a subject. So that's why we did it, to kind of introduce you to this idea of binomial in a fun way that's not a actual test, just silly Glignit stuff.